Hello everyone, welcome to another video. So in this video we'll be discussing about the different applications of determinants. We are going to focus on how to use determinants to solve an equation. So we'll be discussing mainly linear equations with 2 or 3 variables. So first of all, there are two systems of equations. First type is known as the consistent type and the second one is known as inconsistent. So consistent, it refers to those equations that have one or more solution. When an equation has one or more solutions for its variable, it is a consistent type, whereas if it has no solution, it is known as inconsistent. That is, if it has any solutions, it will be consistent. No solution means inconsistent. So for example, now if you are having 3 different equations with 3 variables, x, y and z, right? So now we have to find the values of x, y and z. So for that, what we have to do means, first we can divide these equations into 3 different matrices. So first matrix is matrix A. It will be such that it has all the coefficients. So the first row, it will be for the first equations coefficients of the variables. So a1, these are like x variables coefficients, these are y variables coefficients, and these are z variables coefficients. So a1, a2, a3, they are for x, that will be the first column. For y it will be b1, b2, b3, that will be the second column, and for z it will be c1, c2 and c3, so that will be the third column. So then next we are having second matrix x, which includes all the variables. It will be x, y and z. Actually it should be in column wise only. These 2 matrices, they are column matrices. So x, y and z. Then third one, it's the B matrix. It has all the answers for the equation like d1, d2 and d3. So you'll be writing it down. So when we do the multiplication, like if we do the multiplication a into x, it will be equal to b, because a1 into x plus b1 into y plus c1 into z, it will be equal to d1. It will be like the same equations we are getting from these matrices. So now we need to find the value of x, right? So to solve this one, what we are doing means, to remove this a, what we have to do means we have to multiply it by a inverse, this side and the other side also. So we are multiplying it by a inverse before to remove it. So before this a, we are having an a inverse. So on the other side of the equal to sign also, you have to add an a inverse before the b. Here we added before a, so here also before itself. So when we are doing a inverse a or a into a inverse, any order if you do, you will get the answer as the identity matrix itself. Identity matrix means it's a square matrix with all the diagonal elements as 1. So any matrix, when it is multiplied with the I matrix, that is the identity matrix, you will get the same matrix itself. So here x is multiplied with I, so you'll be getting the same x itself, and the other side it will be the same. No need to do any changes. So if you check, this is the required method of solving for the x matrix. We need the variables, right? X, y and z, which is present in the x matrix. To solve this, we have to use this equation. X is equal to a inverse b. So if you are given any equation, first you have to find a. From the a you have to find the a inverse, and then multiply this a inverse with b to get the answer for x. So first of all, when an equation is given, what we have to do means, after finding a, x and b matrices, then you have to first find the a determinant of a. So you have to check if it is equal to 0 or not. If it is not equal to 0, that means it is a non-singular matrix, right? Then only you can find for x variable, that is the x equation, the x matrix. You can solve it and get for x, y and z variables the values. Only if the determinant it's not equal to 0, then only you can apply this equation. Otherwise, if it is equal to 0, we have two different conditions and two different cases. The first one is like adjoint of A, if it is multiplied with B, you have to check. Okay, in both the cases you have to check if the determinant is 0. Then adjoint of A times B, if it is not equal to 0, then the given equation is inconsistent. That means it has no solutions. Otherwise, if it is equal to 0, it can be either it can have many solutions or no solution, but usually you'll be writing it as consistent, but you cannot find the solutions because many different possible solutions are there, right? But in this case, no solution will be there if you apply this equation doing the multiplication of adjoint A with B matrix.